The National Electrical Code, or NEC, does not directly specify the size of the uninsulated grounding conductor in service entrance, or C, and underground service entrance, or use cables in relation to the insulated conductors. Instead, the sizing of the grounding conductor is typically determined and specified by the manufacturer of the cable itself. This practice means that the cable manufacturer takes responsibility for ensuring that the grounding conductor is adequately sized to safely carry fault current. To understand this better, it is crucial to know the purpose of a grounding conductor. A grounding conductor, also known as the equipment grounding conductor, provides a low impedance path for fault current to return to the source. This low impedance path facilitates the operation of overcurrent protective devices like circuit breakers or fuses during a ground fault. The goal is to quickly clear the fault and minimize the risk of electrical shock or fire. When a fault occurs, a large current flows through the grounding conductor back to the power source. The size of the grounding conductor must be sufficient to handle this fault current without overheating or causing a voltage drop that could impede the proper operation of the overcurrent protective device. Manufacturers typically size the grounding conductor based on several factors, including firstly, the ampacity of the insulated conductors in the cable, secondly, the available fault current at the service location, thirdly, the material of the grounding conductor, which is typically aluminum or copper, and fourthly, the installation environment, which may include considerations for corrosion or mechanical protection. The ampacity of the insulated conductors provides a baseline for the expected load current the cable will carry under normal operating conditions. The grounding conductor must be able to handle fault currents that are proportional to this normal load current. Available fault current refers to the maximum current that could flow during a fault condition. This value is determined by the utility company and depends on the size of the transformer serving the location and the impedance of the service conductors. The grounding conductor must be sized to handle this worst-case fault current scenario. The material of the grounding conductor, whether aluminum or copper, affects its ampacity and conductivity. Copper has a higher conductivity than aluminum, so a smaller copper conductor can carry the same amount of current as a larger aluminum conductor. The manufacturer will take this into account when determining the appropriate size. The installation environment can also influence the size of the grounding conductor. For example, if the cable is installed in a corrosive environment, the manufacturer may specify a larger grounding conductor to compensate for potential corrosion-related degradation. While the NEC does not directly specify the grounding conductor size for SE and use cables, it does provide general guidelines for equipment grounding conductor sizing in Article 250. These guidelines are typically used by manufacturers as a starting point for their sizing calculations. It's important to note that the manufacturer's specifications should always be followed to ensure compliance with safety standards and to maintain the integrity of the electrical system. In the specific example provided, 4/0 aluminum insulated conductors are used for a 200 amp service, and they are accompanied by a 2/0 aluminum uninsulated grounding conductor. This sizing is likely based on the manufacturer's calculations and testing to ensure that the 2/0 aluminum grounding conductor can safely handle the expected fault currents for a 200 amp service with 4/0 aluminum conductors. To further illustrate this, let's consider a typical scenario for a residential service entrance. A 200 amp service is commonly wired with 4/0 aluminum conductors or equivalent copper conductors. The manufacturer of the SC or use cable will have designed the cable assembly to meet specific safety and performance requirements. This design includes the appropriate size of the uninsulated grounding conductor. The manufacturer's decision takes into account the potential fault current that the grounding conductor might have to carry during a short circuit or ground fault condition. Factors influencing the grounding conductor size include the cable's overall ampacity, the type of insulation used on the phase conductors, and the materials of the conductors themselves, which can be either copper or aluminum. Copper is generally more conductive than aluminum, so a smaller gauge copper conductor may be used in place of a larger gauge aluminum conductor for the same ampacity. When a fault occurs, the grounding conductor provides a low impedance path for the fault current to return to the source, typically the transformer. This low impedance path helps to ensure that the overcurrent protection device, such as a circuit breaker or fuse, trips quickly to clear the fault. The grounding conductor must be sized appropriately to handle the fault current without overheating or causing a significant voltage drop, which could delay the tripping of the overcurrent protection device. The manufacturer's selection of the grounding conductor size is also based on testing and certification by organizations such as Underwriters Laboratories, or ALL, or other nationally recognized testing laboratories, or NRTLs. These organizations set standards for the safety and performance of electrical products, and manufacturers must comply with these standards to obtain certification. The NEC provides tables and guidelines for sizing equipment grounding conductors in general. For example, Table 250.122 provides minimum sizes for equipment grounding conductors based on the rating or setting of the overcurrent protective device in the circuit. However, these tables are not directly applicable to the uninsulated grounding conductors in SE in use cables, as the manufacturer has already taken these factors into account when designing the cable assembly. It is important to always follow the manufacturer's instructions and specifications when installing SE in use cables. Using the correct size and type of cable is essential for ensuring the safety and reliability of the electrical system. Attempting to modify or alter the cable assembly in any way could compromise its performance and potentially create a safety hazard. In summary, the NEC relies on the cable manufacturer to determine the appropriate size of the uninsulated grounding conductor in SE in use cables. The manufacturer considers factors such as the ampacity of the insulated conductors, the available fault current, the material of the grounding conductor, and the installation environment. Always follow the manufacturer's instructions and specifications when installing these cables to ensure a safe and reliable electrical system. Additionally, understanding the fundamental principles of grounding and bonding is essential for anyone working with electrical systems. Grounding provides a path for fault current to return to the source, while bonding ensures that all metal parts of the electrical system are at the same electrical potential. Proper grounding and bonding help to minimize the risk of electrical shock and fire. Always consult with a qualified electrician if you have any questions or concerns about grounding and bonding requirements. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Furthermore, it is crucial to stay updated on the latest changes and revisions to the NEC. The NEC is updated every 3 years, and each new edition may include significant changes to grounding and bonding requirements. Staying informed about these changes will help you to ensure that your electrical work is in compliance with the latest safety standards. In addition to the NEC, local codes and regulations may also have specific requirements for grounding and bonding. Be sure to check with your local building department or electrical inspector to determine if there are any additional requirements in your area. Remember, the safety of yourself and others depends on proper grounding and bonding. Take the time to learn about these important concepts and always follow the manufacturer's instructions and specifications when working with electrical equipment. In conclusion, while the NEC does not explicitly dictate the size of the uninsulated grounding conductor within SE and use cables, its broader guidelines and the manufacturer's specifications ensure the safe and effective operation of the electrical system. The manufacturer's responsibility in determining the grounding conductor size is paramount, as they consider all relevant factors to ensure adequate fault current carrying capacity and overall system safety.